Surprise, this is Miss Brown. Today we are doing sequences and summation notation part 2. Are you ready?
I started to give you this voice again, but I'm back. Partial sums are all sums today. A partial sum means sum of part of a sequence. And so if you have those terms, A1, remember A1 means first term, second term, third term. The partial sums are just what you think. The sum of the first term is just the first term. These, by the way, S2 means sum of the first two terms. You just add the first two. Sum of the first three, add the first three, so on, so on, so on. S is called the first partial sum. S2, so we just said that. Sn is the nth partial sum. And if S1, S2, S3, all the way to Sn is called the sequence of partial sums. All right, so let's find the first four partial sum and the nth partial sum of the sequence given by 1 over 2 to the n power. So you got to find the terms first. So I need to find the first term. Just plug in the 1 over 2 to the first power. Supposed to be a 1 there. Come on now. There we go. Which is 1/2. The second term is 1 over 2 squared, which is 1/4. The third term, 1 over 2 cubed, which is 1/8. And the fourth term, 1 over 2 to the fourth, which is 1/16. Now, to find the first four partial sums, that is the first partial sum. The second partial term, S2, would be the first term, probably the first sum plus the second term, which is going to be 3/4. The third partial sum is going to be the sum of the first three, which is the sum of the first two is 3/4 plus 1/8, which is 7/8. And the fourth partial sum will be the sum of the first three, which is 7/8, plus the fourth term, which is 1/16, which would give you 15/16. Okay, so then it asks us to find the nth partial sum. Run out of room here. The nth partial sum is basically like we did yesterday, is find the sum, finding a pattern for the sums, right? So I went 1/2, 3/4, 7/8, 15/16. So the bottom again is going 2, 4, 8, 16. It's just, it's just 2 to the n power, 2 to the first, 2 squared, 2 cubed. If I'm looking at my numerators, the numerator is 1 less than the denominator every time. So that means it's going to be the same as the denominator except 1 less. So that right there should represent the sum, the nth partial sum. All right, when it says nth, it's talking about a formula every time. Okay, this one says find the first four partial sums and the nth partial sum of this sequence. Looks a little more difficult. Let's see what happens here. The first sum is really just the first term, which would be 1 over 1 minus 1 over 2, which is really 1 minus 1/2. I'm going to leave it like that for a second. The second sum would be the first term minus or plus the second term, which should be 1/2 plus 1/3. Now look at that. What's going to happen there? The 1/2s are going to cancel, so I get 1 plus 1/3. That should be 1 minus, I forgot the sign there. 1 minus 1/3. Sorry about that. Sum of the third term, sum of the first three, would be sum of the first two, which is 1 minus 1/2 plus 1/2 minus 1/3 plus the third one, which should be 1/3 minus 1/4. Now watch what happens here. The 1/2s cancel, the 1/3s cancel. It gives me 1 minus 1/4. I think we're seeing a pattern here. The fourth partial sum, which is the last one we got to find, are the sum of the first three, which is actually 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 plus the next term, which would be 1/4 minus 1. Come on now, minus 1/5. It's my hand making it move. And sorry about that. And look what happens. Those cancel, those cancel, those cancel. You get 1 minus 1/5. So those are the first four partial sums. And you could reduce them. Obviously, make the first one be 1/2. That'd be 2/3. That'd be 3/4. That'd be 4/5. So the partial sum is really, if you look at it, the nth sum is going to be 1 minus, and then look what's happening. 1 over whatever n is plus 1. Okay, the first term, the n is 1. 1 plus 1 is 2. Second term, 2 plus 1 is 3. Third term, 3 plus 1 is 4. Fourth term, 4. It just keeps on going and going. That's pretty awesome. Sigma notation. I think you've seen sigma notation before. A couple things about sigma notation. First of all, sigma means sum. That's a summation symbol. The number on the bottom is the first number you plug into whatever formula or sequence they give you here. The number on the top is the last number that you plug in. So, and then you just add them up. Like you plug in the bottom number 1, you get A1, you get A2, A3, all the way until the AM, and then it means sum. You must add those terms together before you get done too far. Okay, here we go. Find each sum. The first one says k equals 1 to 5 with k squared. So what I'm going to do is I'm going to plug the 1 in there. 1 squared is 1. I'm going to plug 2 in there. 2 squared is 4. Plug 3. 3 squared is 9. 4 squared, 5 squared, and you're going to add all those up. Let's see, that's 5, 30, and 20. I think that's 55 when you add all those up. And look at B also. Do the same thing here. Notice what's on the bottom this time, 3. So I'm going to plug in a 3 on the bottom, then a 4, then a 5. Going to add all those up together. LCD would be 60. And you're going to get 47 over 60 when you add those 3 numbers up. Okay, so that's all the sigma means you need to do. Sigma means sum or summation. All right, write each sum. Okay, now we're going backwards like they've been doing this to us all day long. Okay, first of all, let's look at part A. Draw your sigma. Notice it starts with 1, so I'm going to put K is 1. It goes to 7, so I'm going to put to 7. And all they're doing is they're cubing each number, like 1 cube, 2 cube, 3 cube. So that's all you have to do on that one. Okay, hopefully that's not too bad. All right, part B. I'm going to go again here. It's like square root of 3, square root of 4, square root of 5. So this time I'm going to start my bottom number at 3. I'm going to go all the way to 77 because 77 is my last number in there. And my pattern is going to be square root of K. Meaning the first thing you're going to do is plug in 3. The last thing you're going to do is plug in 77. That's going to get you the whole sequence. That looks great. One more slide. All right, properties. So this is just no problems, just properties that you can do with sigma. If you have sigma and you have a parentheses with 2 terms added together or 2 formulas added together, you can break them up and do 2 different sigmas. Same thing with subtraction. You can break them up. And the last thing, if you have a constant inside your sigma, then you have a function. Like let's say you had 2 times k minus 2 or something like that. You could pull the 2 out, put it in front, just do all the k minus 2's, add those up, and then multiply your final answer by 2. So those are just a couple of properties that you might want to use when you're working on some of these sums, and maybe not, who knows. So anyway, hope that wasn't too bad. Work on that in class tomorrow, as always. Hope you enjoy my wife talking about the first slide. She's got a great voice. See you tomorrow.